Okay, so the Colquitts River is located in Saanich, BC, Canada. Um, the whole watershed system gets its source from lakes and various sub-watershed systems like creeks. Examples of this will be Beaver Lake, Swan Lake, and a large portion of Swan Creek. The stream flow of this river eventually drains at the Portage Inlet in the ocean, and overall the river is 9.5 kilometers long. The channel pattern of Colquitts River follows a meandering winding pattern. Evidence of this at the river is bluffs, floodplains, point bars, and the undercut banks. Essentially what happens is instabilities cause the Thalweg to change direction, um, and hit sort of the banks of the river, and the hydraulic action causes a lot of erosion, and that causes a positive feedback loop where the river becomes meandering and um, eventually has this 30 turning pattern that kind of is happening overall. This also tends to happen with sort of rivers on a gradual slope, which is the case for this river as well. The biogeoclimatic zone of this river is in the Douglas Fir Maritime Moist Zone. Um, Basically, that means that the summers are warm and dry, and the winters are relatively mild and just very wet. Um, there's many different ecosystems this passes through, such as the Gary Oak savannas, which are actually quite dry, and the moist red cedar area. So this river passes through a lot of little different microclimates. As you can see here, I have a climate graph that shows that the precipitation is much lower, and the heat, there's a lot more heat and higher temperatures in the summer. And then in the winter, you have the highest amounts of precipitation occurring in November, um, and some of the coldest temperatures occurring in these winter months. Um, in terms of discharge, the average discharge of the river is 1.7 meters squared per second for annual, but it varies quite a bit monthly, in the August being the lowest month and November being the highest month of discharge, most likely linked to the precipitation. Um, the topography of the area has a sort of topographic gradient of a sort of gradual small slope, so it's a pretty flat land. Um, the superficial geology is very sedimentary, so when you see the erosion on the riverbanks, there's a lot of peat and clay. And as for land cover, the river itself is in a very vegetated coniferous forest, but the surrounding area of land cover is highly urban residential, which means water flows in much quicker. And then as for the landscape topography, it's overall quite a vegetated landscape. And I'd say there's some small hills in the area. Just as an example here, I'm showing you there's sort of like some grassland sort of around it, and you can see the coniferous trees, but the surrounding area you see is completely residential, and there's some cases of fragmentation, and this whole park is quite broken up from this urban development. Okay, so to give some background, here is Beaver Lake, which sort of feeds into this Colquitts River Trail, and Swan Lake down here, and then it ends out here in the Portage Inlet. But the area I'm focusing on is the Colquitts River Trail, which is in Royal Oak. So if you want to go to it, you can just come off of Mackenzie, find an exit, and get into the Royal Oak sort of like neighborhood suburban area, and there is multiple trails that connect it through the neighborhood, and as you can see, it goes through. You cannot see the river because it's very vegetated, and the river itself is quite small, but as you can see, this is where I went specifically to find it, just right here. So here we are at the Colquitz River Trail, and as you can immediately see, the river itself has a meandering, winding channel pattern, and the area is quite vegetated with not a lot of sunlight, so it's quite a moist environment. So, a big characteristic of the river's meandering pattern is the point bars that you can see throughout. So, point bars occur when there's lower velocity on the inner portion of the meander, causing a lot of sediment to accumulate and be deposited on the river bank. So, right here, we can see sticks from the bedload of the river basin sort of being deposited on the side there, sort of being caught up there. And right here, rocks from the bedload of the river are deposited on the side of the riverbank here, creating that look. So, sort of opposite to point bars, we have cup banks. So, cup banks occur on the outer portion of the meander in meandering streams. The cup bank is kind of produced by the high velocity of water that's coming at it, which does sort of a lateral, like a erosive action, which causes the bank to be steeply cut, exposing all the layers of sediment, such as clay and peat in this case. And basically it'll expose the roots of the trees right here, and it can sometimes do an undercut as well. So the third feature is the nick point, and nick points occur when there's a sudden change or in slope or topography, which causes the gradient profile of the stream to be changed. So basically, if there's rocks like in the way, it'll create rapids or like a waterfall kind of look to it. Or if there's just a major change in slope where it drops down like this, that will also create that sort of cascade effect that what we're seeing right now, right here. So topography and stream discharge are two factors that control the fluvial geomorphology of rivers. So basically, higher levels of discharge would be responsible for larger point bars. The faster velocity would probably intensify the erosion on cut banks, and with increased discharge, it would perhaps it would intensify the rapids at nick points because of like the increased gradient. As for topography, the soil matters a lot. Certain soil and sedimentary components can be transported easier, and certain soils erode easier for like cut banks, and a more rocky topography will create larger gradients for nick points. Overall, this project helped me understand the form, function, and numerous factors that affect rivers, as well as give me a better understanding as to why we have restorative practices.